Okay, good afternoon to everybody. Today we'll discuss how to find the maximum and minimum values of a function in any to optimize the function. That means you have to find out the maximum and minimum values of a function. In our previous lectures, we have discussed about the extreme point or what is maximum point or what is minimum point, what is relative maximum and relative minimum, what is decreasing function, what is increasing function. Okay, so today we'll discuss about the what is how to find maximum and minimum values of a function and how to find the inflection point or and critical points also by using first derivative test and second derivative test. In our previous lecture, we have studied what is inflection point. I am reviewing it. What is inflection point actually? A point on the graph of a continuous function where the tangent line exists and where the concavity changes is called inflection point. In previous lectures, we have discussed about concavity, concave down and concave up with the geometrical interpretation. So first of all, follow the previous lecture, then you can understand this. So a point on the graph of a continuous function, this is the continuous function, and this point is inflection point. How? Because concavity changing at this point. The concavity changes is called inflection point. So how to find the actually inflection point? To find the inflection points, we have to compute the second derivative of the given function, then determine the number of domain of f for which second derivative is equal to 0 or second derivative does not exist, and to determine the sign of second derivative of that function to the left and right of each number c found in step 2 in this 2, and if there is a change in the sign of this second derivative of that function, we move the across x equal c where c comma fc, and this point will be the inflection point of f. Now we'll try to solve an example applying this principle. Now we'll try to solve this problem. Example 4: the given function y equals to x cube minus 3x square plus thrice x. Find the point of inflection. Okay, first of all, dy dx, we have to find out the differentiation of the given function. This is the given function. First of all, dy dx equals to what will be differentiation of x cube, what 3 into x to the power 3 minus 1, that means thrice x square, minus 3 x square differentiation what 2 into x to the power 2 minus 1, that means minus 6x, and x differentiation what 1, so only 3. So dy dx, we have to find out the first derivative of given function, then dy dx equals to what 3x square minus 6x plus 3. The first condition, we have to find out the first derivative equals to 0. Okay, so if we take the first derivative equals to 0, that means this equals to 0. 3x square minus 6x plus 3 equals to 0. So after solving this equation, taking common 3x square minus twice x plus 1 equals to 0, then this is actually a minus b whole square formula, that means x minus 1 whole square formula. This equals to, that means x equals to 1. So for dy dx equals to 0, we get x equals to 1. Now another, taking a second derivative, the second condition what will be taking second derivative, that means d2y dx square, d2y by dx2, that means d square y by dx square. Second derivative can be written as like this. Okay, so taking another again differentiation of this is equation number 1, then dy dx equals to this, then taking another ddx on both sides. So d square y dx square, what will be x square differentiation, what will be 2 twice x, that means we get 6x. Okay, now x differentiation what 1, so only minus 6, and 3 will be 0. So second derivative will be what 6x minus 6, then taking second derivative equal to 0, we get x equals to 1. So second derivative 0 when x is 1. Now again taking differentiation, of third derivatives, d cube y by dx cube equals to 6, which is not 0. Then we get the inflection point is x equals to 1, and putting x equals to 1 in equation 1. Putting x equals to 1 here, we get y equals to what? We get y equals to 1. So the 1, 1 will be the inflection point in this case. Okay, given in this example, given the function y equals to x cube minus thrice x square plus thrice x, and we have to find the inflection point. Okay, now we are given y equals to x cube minus thrice x square plus 3x. Okay, this is equation number 1. Then taking differentiation with respect to x on both sides of 1. Both sides of 1 we get okay, the dy, that means ddx, taking ddx on both sides, of 1, we get this. Now just simple differentiation, x to the power n formula, that means power rule, applying power rule in our previous lecture, 3 into x to the power 3 minus 1, and x square differentiation what? 2 into x to the power 2 minus 1, and x differentiation what? 1. So we get only this one. Okay, x differentiation what? 1. So dy dx equals to what will be? Thrice x square minus 6x plus 3, and this is equation number 2. So taking differentiation with respect to x on both sides of 1. Okay, dy ddx, taking ddx on both sides, we get ddx of y equals to ddx of this right hand side. Now just using power rule, 3 into x to the 3 minus 1, x to n formula, minus 3 into x square formula, 2 into x to the 2 minus 1, 3 into x differentiation what? ddx of differentiation of x with respect to x will be 1. So we get only dy dx equals to what? 3x square minus 6x plus 3. This is equation number 2. Okay. Now first condition for the finding the inflection point, first condition what will be? dy dx will be 0. Then at which point dy dx equals to 0? Actually, because first derivative equals to what? 3x square minus 6x plus 3. So this, putting these values here, we get, taking 3 common, we get x square minus twice x plus 1 equals to 0. So this is actually x minus 1 whole square formula. Okay, just dividing by 3 on both sides, we get x minus 1 whole square equals to 0. Taking a square root, we get x equals to 1. So first derivative equals to 0 if x equals to 1. Now taking second derivatives of equation 1. So taking an again ddx on both sides of 2, we get second derivative. Okay, d square y dx square, this is the second derivative notation. And x again using same rules, power rule, 3 into x to the 2 into 2, 2 into x to the 2 minus 1 minus 6 into derivative of x will be 1 plus 3 differentiation what will be? Constant differentiation is 0. So from this we get 6x minus 6. That means second derivative is equal to what? 6x minus 6, and it is equation number 3. Now second condition what will be? Second derivative will be 0 at higher, we are finding. Same, second derivative equals to 0. That means 6x minus 6 equals to what? 0, because d square y by dx square means this. So taking 6 common, we get x minus 1 equals to 0. So x equals to 1. So second derivative also 0 or x equals to 1. Now we are testing for third derivative. Now taking third derivative. So from both sides of 3, that means taking another differentiation here, we get third derivatives. Okay, d cube y by dx cube. Okay, 6x. But third derivative is positive. So you have to stop here. Okay, third derivative is positive. That means not 0. So the inflection point where will be? At x equals to 1. So putting x equals to 1 in equation 1, putting x equals to 1 in equation 1. Equation 1, which one? This one, given equation. So we get y equals to 1 there. So the inflection point will be what? X comma y equals to 1 comma 1, and this is the actually finding inflection point for this question. Now another example for you, show that the curve y equals to x square into 3 minus x has a point of inflection point at the point 1 2. Okay, we have to prove this as a inflection point. Okay, same using same procedure we can find this. Okay, now another example, show that the function y equals to x square into 3 minus x has a point of inflection at the point 1 2. Okay, so we have to show that this is the inflection point. We'll use the same procedure here. Okay, same procedure. Okay, show that the function y equals to x square into 3 minus x has a point of inflection at the point 1 2. Okay, this is the inflection point, we have to show that. So we are given the function y equals to what? X square into 3 minus x. So x square into 3 minus x, and we have to find out the inflection point of this curve. So multiplying x square by this, we get 3x square minus x cube, and this is equation number 1. This is the given equation. So taking differentiation with respect to x on both sides of 1, we get ddx, taking ddx on both sides. Okay, ddx 3x square minus x cube. So 3 into we using power rule, 2 into x to the power 2 minus 1 minus 3 into x to the power 3 minus 1, we get actually 6x minus thrice x square. Okay, so dy dx equals to what is here? 6x minus 3x square. This is equation number 2, and this is the first derivative of the given function. So for the first condition, we get dy dx what will be 0. Then at what point we will testing? So 6x minus 3x square equals to dy dx equals to 0. Just we get x into 2 minus x equals to 0. That means either x equals to 0 or 2 equal to 2 minus x equals to 0. That means x equals to 2. At this point, we get first derivative is 0. Now, the first derivative is 0 if x equals to 2. Now taking second derivative of 2. Taking second derivative from this equation number 2. That means taking ddx on both sides. We get second derivative. Taking ddx on both sides of equation 2. We get the second derivative of equation 1. So d square y by dx square what will be? X differentiation what? 1. And x square differentiation what will be? 2 into x to the power 2 minus 1. That means using power rule, x to the power n formula. N into x to the power n minus 1. So we get 6 minus 6x. Okay, that means what? 6x. So second derivative d square y dx square equals to what will be? 6 minus 6x. This is equation number 3. Now second condition will be 0 at where we are testing. 6 minus 6x equals to 0 because second derivative equals to what? 6 minus 6x. So taking common 6, we get 1 minus x equals to 0. That means x equals to 1. So now again taking the third derivative. Taking third derivative of given equation, that means taking ddx on both sides from of 3, we get third derivative. Okay, ddx, that means d cube by dx cube what will be? Differentiation of 6 will be 0 because constant differentiation what? Constant rule. Using constant rule we get 0 here, and x differentiation what? 1. So ddx of minus 6 only. So that is, it is not 0, that means negative. So inflection point occurs here because in our previous lecture we have studied about increasing and decreasing function, concave up, concave down. You must know what is inflection point. The inflection point is where concave up and concavity occurs. at that point. That means concavity occurs at this point. At this what? X equals to 1. At this point, concavity occurred. This is why we are getting not 0 here. Third derivative is not 0. So for inflection point, we get x equals to 1. That means at x equals to 1, the given curve becomes what? Inflection point. That means concavity occurs. So putting x equals to 1 in the given equation, we get y equals to given equation what here? This is the given equation. Okay. So using x equals to 1 here, we get y equals to 2. That means we get the inflection point is x equals to 1 and y equals to 2. That means x comma y equals to what? 1 comma 2. And it is our desired result, because we have to show that 1, 2 is the inflection point. Now another example 45, show that the function y equals to x into e to the power minus x has a point of inflection at x equals to 2. We have to prove that this curve has inflection point at x equals to 2. We are given y equals to x into e to the power minus x, thus taking first derivative then with respect to x on both sides of a given equation, we get this one, and second derivative and third derivative. Using similar procedure, we get the same one. Okay. Okay, show that the function y equals to x into e to the power minus x has a point of inflection at the point x equals to 2. Now we are given y equals to x into e to the power minus x, which is equation number 1. Taking differentiation with respect to x on both sides of equation 1, we get, that means taking ddx on both sides as same procedure of the previous two examples. ddx, we get this x into e to the power minus x. Since this is the product of two functions, so you have to using the rules for product of two functions. Okay, in differentiation, what was the rule? First function into ddx of second function plus second function into ddx of first function. Okay, that means u into ddx of b plus b into ddx of u. So x into e to the minus x formula, what will be? Minus here minus 1. Okay, because e to the power mx formula what? M into e to the power mx. You can write the formula e to the power mx means what? M into e to the power mx plus e to the power minus x will be same, and x differentiation what? 1. So from this we get, taking e to the power minus x common, we get what? 1 minus x. And so first derivative of the given function dy dx equals to what? E to the power minus x, 1 minus x, and this is equation number 2. Now using first condition what was for inflection point? First derivative will be 0. At which point first derivative is 0, we are finding. That means e to the power minus x, 1 minus x equals to 0. Since dy dx equals to what? E to the power minus x, 1 minus x. So from this we can write 1 minus x equals to 0, because e to the power minus x can never be 0 for every x. For any x of real number, e to the power minus x can never be 0. So dividing by e to the power minus x on both sides, we get this 1 minus x equals to 0. So x equals to 1. So first derivative is 0 for x equals to 1. Now taking another derivatives, that means second derivatives of equation of the given equation, that means taking taking ddx on both sides, we get second derivatives from 2 with respect to x. So taking ddx on both sides with respect to x, we get d square y dx square, what will be again ub process. Again e to the power minus x is u and 1 minus x is b. That means e to the power minus x is first function and 1 minus x will be second function. So product rule of two functions in derivatives, we must know first function into ddx of second function plus second function into ddx of first function. This is the rule for product of two functions. So second derivative equals to what will be? E to the minus x this, and 1 minus x, 1 differentiation what will be? 0. 1 differentiation what? 0, and x differentiation what? 1. So 1 minus x same, and e to the minus x formula what will be? Minus 1 into e to the power minus x. Just multiplying with the coefficient of x. Remember it. So from this we get e to the power minus x, taking e to the power minus x common, we get what? Actually, x minus 2, x minus 2, equation number 3. Now, using second condition, second derivative, taking second derivative is 0, at which point we are testing. So this is the second derivative values. Okay, second derivative values. So e to the minus x is not equal to 0. This is why dividing by on this on both sides, we get x minus 2 equals to what? 0. So x equals to 2. Now taking third derivative. So from the third derivative of given function, that means taking ddx on both sides of 3, we get this one, d cube by dx cube from here. So again UV process. Okay, this is the first function and this is the second function, product of two functions in derivatives. First function ddx of second function plus second function into derivatives of first function. So e to the minus x same, and x differentiation 1 minus 2 0. So x minus 2 will be same, and e to the minus x differentiation what will be minus 1 into e to the minus x. So from here taking e to the minus x common, we get 3 minus x. Okay, so remember it, for the previous x equals to 2, this is what? Positive. This is positive. That means third derivative is not 0 at x equals to 2. So x equals to 2 is the inflection point. Okay, so x equals to 2 is the what? Inflection point. Hence the inflection point is x equals to what will be? X equals to 2. And this is our desired condition. That means we have to show that the function y equals to x into d minus x has a point of inflection at this point. That means at x equals to 2. So practice these 3 examples and follow the previous lectures. I hope everybody understand what is the actually maximum and minimum of a function, what is the concavity, what is the derivative test, first derivative test, second derivative test, and then what is the inflection point. Okay, so first of all follow the lectures, then you can understand better. Thanks to everybody. Okay, good afternoon to everybody. Now we will try to understand how to find the maximum and minimum values of a function. Actually maximum minimum we have to use in business purpose, in economics, in business we have to find out the maximum profit and minimum cost, or maximum revenue or maximum profit in everywhere of economics and business. So we'll try to find out now the with example, find how to find the maximum and minimum values of a function. Okay, now we'll try to solve this example 47. Investigate the maximum and minimum values of the function twice x cube plus thrice x square minus 36x plus 10. Now we'll try to solve this problem. How to find the maximum and minimum values of this function.
No?
No. Now number 1 example, that means 47 from the text. Investigate the maximum and minimum values of the function. Investigate the maximum and minimum values of the function y equals to twice x cube plus 3x square minus 36x plus 10. First of all, we are given the given function is y equals to twice x cube plus 3x square minus 36x plus 10. This is equation number 1. Taking differentiation with respect to x on both sides of equation 1. That means taking ddx on both sides. Same procedure we will just before look like before previous example. Dy dx, taking ddx on both sides, dy dx, that means ddx of this function. Now using power rule, x to the power n formula, 2 into x to the power n means what here? 3 into x to the power 3 minus 1 plus 3 into x square differentiation, what will be 2 into x to the power 2 minus 1 minus 36 differentiation of x, what? 1, and differentiation of constant, what will be? 0. So the first derivative dy dx equals to 6x square plus 6x minus 36. This will be equation number 2. This will be equation number 2. Now first condition for finding maximum and minimum value, we have to use this condition. For maximum and minimum values of the function dy dx, what will be 0? Dy dx must be 0. So dy dx equals to what? 6x square plus 6x minus 36 equals to 0. Okay, so just taking 6 common, we get what? 6 will be 6 common, then x square plus x minus 6 equals to 0. So just middle term factor, making middle term factor x square, this 6 can be written as what? 3 to the 6. Okay, so plus thrice x and minus twice x will give this factor to x. So just taking middle term factor, we get x plus 3, x common, x plus 3 and minus 2 common from this 2, we get x plus 3. So x plus 3 and x minus 2. Remember, this 6 is positive number, so dividing on both sides, 6 is gone. So either x plus 3 equals to 0 or x minus 2 equals to 0. So we get 2 points for x equals to minus 3 and x equals to 2. Remember it, taking dy dx equals to 0, we get these points of x. So this is the critical point, okay, of the function, given function, x equals to minus 3 and x equals to 2. Now again taking differentiation with respect to x on both sides of 2, equation 2, again taking second derivatives of the given function. So we get d dx over dy dx equals to d dx of from equation 2. Now these second derivatives will be given by 6 and x square differentiation 2 into x to the 2 minus 1 plus 6 into x differentiation what? 1, and this will be what? 0, because 36 is constant. So we get only 12x plus 6. So second derivative is equals to what? 12x plus 6. This is equation number 3. Now another condition, second condition, what will be? Second derivative test. We have to test whether it has maximum or minimum. Suppose we had two values of x. Suppose taking one x values for x equals to minus 3, second derivative value what? For x equals to minus 3, putting here 12, x equals to minus 3 plus 6. So we get minus 30. Second derivative value what? Negative. Second derivative what? Which is negative. So this is the negative value. So the function has maximum at x equals to minus 3 because negative sign. If the second derivative test is negative, then the function has maximum, and if the second derivative test will give the positive value, then it will have minimum. Remember it. So there are negative value. This is why the function has maximum value at x equals to minus 3. Now the maximum value is from equation number, given equation, from the given function, equation number 1. This is the equation number 1. Okay, just putting x equals to minus 3 here. Putting x equals to minus 3, we get 91, and 91 is the maximum values, y max. That means maximum value of y. Okay, again these lines, all lines will be same, just for x equals to minus 3. Again for x equals to what? To another critical point, x equals to 2. Just x equals to 2, second derivative values will be what? 12 into 2 plus 6. 12 into 2 plus 6, that means 24 plus 6, that means 30, which is positive. That means the function has minimum value. The function has what? Has minimum at x equals to 2, and the minimum value is what will be? Just from equation number 1. That means given function. Okay, just y mean what will be? 2 into putting x equals to 2 x cube, 3 into x square minus 36 x equals to 2. That means this will be given by what? Minus 34. So maximum value of the given function is 91, and the minimum value of the given function is minus 34. As the maximum value is y max equals to 91, and minimum value y min equals to what? Minus 34. And this is the result. Okay, another example, investigate the maximum and minimum values of the function y equals to x cube minus 2x square minus 4x minus 1. So we are given y equals to this. This is equation number 1, given function. Taking differentiation with respect to x on both sides of equation 1, we get just taking ddx on both sides of 1. So dy dx can be find out. So ddx of this. Now using power rule, 3 into x to the 3 minus 1 minus 2. X square formula what will be 2 into x to the 2 minus 1. X to the power n formula. N into x to the power n minus 1. Then x differentiation what 1 differentiation of constant rule what 0. So we get 3x square minus 4x minus 4. This is equation number 2. So first derivative is this. Now first condition for finding maximum minimum values, for maximum and minimum values dy dx what will be 0. We must remember this condition. Now this can be written as, because dy dx equals to what 3x square minus 4x minus 4 equals to 0. Okay, just taking factorization, making factorization of this middle term factor, 3x square minus 6x plus 2x minus 4 equals to 0. 6 and 2 why? Actually this 4 and this coefficient x square coefficient 3 will be multiplied. 3 multiply 4 what 12. So 6 to the 12. Then 6 minus 2 will be what 4. So minus 6x plus 2x will be minus 4x. This is why middle term factor like this. Now thrice x will be common, then x minus 2, and 2 will be common from these two, x minus 2. So x minus 2 are again common, we get x minus 2 into thrice x plus 2 equals to 0. So either x minus 2 equal to 0 or thrice x plus 2 equal to 0. Therefore x equals to 2 and x equals to minus 2 by 3. So we get the critical point, x equals to 2 and x equals to minus 2 by 3, 2 points. Again taking differentiation with respect to x on both sides of equation 2. Both sides of equation 2 for second derivative test. So ddx of dy dx equals to what will be ddx of 3x square minus 4x minus 4. So second derivative will be d square y by dx square equals to x to the power n formula, n into x to the power n minus 1, that means 2 into x to the power 2 minus 1, x differentiation 1 and constant differentiation what will be 0. So we get 6x minus 4, and this is the equation number 3, second derivative. Now second condition, second derivative test, we will test with the help of critical points. Now for x equals to 2, x equals to 2, first critical point, this one. So for x equals to 2, second derivative values will be what 8, which is positive. Positive means what, the function is minimum at x equals to 2, and the minimum value can be find out just putting x equals to 2 in the given function. Okay, given function which one, equation number 1. Okay, this just putting x equals to 2 here, we get the minimum values minus 9. Again for another values, another critical point was what, x equals to minus 2 by 3. So x equals to minus 2 by 3 will given by second derivative values what, minus 8. Just putting in equation number 3, x equals to what, minus 2 by 3. X equals to minus 2 by 3 will give what, 6 and 3 cut. So this will be 2 and 2 what, minus 4 and minus 4, minus 8, which is negative. Since the function is second derivative test is negative, so the function is maximum at x equals to minus 2 by 3, and the maximum value will be what, just putting x equals to minus 2 by 3 in a given equation, minus 2 by 3 whole cube minus 2 into x minus 4 into x minus 1. Then after simplifying we get 13 by 27. 27 will be LCM. So the maximum value is 13 by 7 and minimum value is what, minus 9, and very easy for you. Okay, using same procedure we can find or investigate the maximum and minimum values of this function. Actually the highest power is 4, so it is 4th degree polynomial. So y equals to, this is given given function, x to the power 4 plus 2x cube minus thrice x square minus 4x plus 4. We are given, this is the first equation, number equation 1. Taking differentiation with respect to x on both sides of 1, we get just taking ddx on both sides. ddx of y equals to ddx of this x to the 4 plus twice x cube minus thrice x square minus 4x plus 4. X to the n using power rule from our previous lecture, 4 into x to the 4 minus 1, 2 into x cube differentiation, what will be 3 into x to the 3 minus 1 minus 3, x square differentiation 2 into x to the 2 minus 1 using power rule, x differentiation what 1, and 4 is the only constant, there is no variable, this is why the differentiation of constant rule what 0, constant will be what differentiation, this will be 0, remember it. So first derivative will be dy equals to 4x cube 6x square minus 6x minus 4. This is equation number 2. Okay. Now first condition for maximum minimum value we must have dy dx what will be 0. That means we have to find out first of all critical point dy dx equals to 0 using this condition, first condition. Then dy dx what will be this 4x cube plus 6x square minus 6x minus 4. This equals to 0. Taking 2 common, we can write 2x cube plus 3x square minus thrice x minus 2 equals to 0. Then factorization, after factorization and simplification, we can arrange this like this, twice x cube minus 2x square plus 5x square minus 5x plus twice x minus 2 equals to 0. Because just taking common here twice x square, we get x minus 1. Here 5x common, we get x minus 1. Here 2 common, we get x minus 1. Okay, this is the actually factorization. After factorization, we get this. Okay. So taking x minus 1 common, x minus 1, we get twice x square plus 5x plus 2. Okay. Again factorization here. Factorization coefficient of x square what 2, and here constant term 2. So 2 and 2 multiply what 4. 4 ones are 4. This is why 4 and 1 will make 5. So factorize using factorize middle term factor, we can write this twice x square plus 4x plus x plus 2 equals to 0. Now x minus 1 again common here twice x common x plus 2, and here no common, only 1 common, this is why x plus 2. Again x plus 2 common here within second bracket, we get at last x minus 1 into x plus 2 into twice x plus 1. So there are 3 values actually, one is x minus 1, another is x plus 2, twice x plus 3. So after factorization of this, solving this for x, we get this 3 values, one either x minus 1 equals to 0 or x plus 2 equals to 0 or twice x plus 1 equals to 0. So we get 3 critical values. Okay, so the function will have maximum or minimum values at this any of these 3 points. So the critical points is x equals to 1, another is x equals to minus 2, and x equals to minus half. Again taking differentiation with respect to x on both sides of 2, equation 2, for second derivative test, we have to take another differentiation here for second derivatives ddx. Taking ddx on both sides, we get second derivative d square y by dx square equals to, using power rule, we get same procedure, we get what 12x square plus 12x minus 6. So second derivative will be what 12x square plus 12x minus 6. This is equation number 3. Now another second condition will be second derivative test to verify whether it is maximum or minimum. So for taking one critical values, x equals to 1, for x equals to 1, second derivative value what will be 18. Okay, just putting x equals to 1 here, x equals to 1 here, so we get only 18, and which is positive. You must know, if second derivative in second derivative test, if it gives positive values, then the function is minimum at x equals to 1. Okay, and the minimum value is what will be from a given equation. Just putting x equals to 1 in given equation, in given function. Okay, so you get 0. Okay, now again testing for x equals to another critical values, x equals to minus half. Okay, x equals to minus half, second derivative values what will be 12 into minus half whole square plus 12 into minus half minus 6. Okay, this will be what minus 6, not minus 4, minus 6. So for x equals to minus half, second derivative value is what? Negative. This equals to minus 6. Minus 6 means what? Minus 18. Okay, which is negative. Which is negative. So the function is maximum at x equals to minus half. Since at second derivative test we get negative values. Negative. This is why the function will have maximum at x equals to minus half. And the maximum value will be from the given function or given equation number 1. Thus putting x equals to minus half in the given equation. Which was given equation actually? This is the given equation. Okay. Number 1 equation. This is the given function. And just putting x equals to minus half, we get the maximum value. And just putting x equals to 1, we get minimum values. So this is the procedure for finding maximum and minimum values of any function. So the maximum value is just simplifying, taking 16 as LCM, we get 81 by 16, and the minimum value will be y min equals to 0. Okay, because y min equals to 0 and y max equals to 81 by 16. And this is the actually procedure for finding maximum minimum values of any function. Okay, this is actually example 4, 5, and 6. Using same procedure, you can solve this for maximum and minimum values. Actually, to investigate 2x twice x cube minus 15x square plus 36x plus 2. You can find out the maximum and minimum values for this function, and this will be homework for you. And I hope everybody can solve this using the same procedure and investigate the maximum and minimum values of this function. This function can be we can find the maximum and minimum values for this function also. Show that x cube minus 3x square plus 3x plus 7 has neither maximum nor minimum value. So we have to show, first of all, we have to find out the first derivative dy dx from this. Then we can find the critical value by setting dy dx equals to 0. But remember that if we find out the second derivatives, that means d square y by dx square, and this will give 0 for every critical values. This is why we have to stop from that. That means if the second derivative value is 0, then this function will not have maximum or minimum values. That means this function has neither maximum nor minimum values. Now the last problem of the day, to find the extreme values of the function this x cube into e to the power minus x. For this function, suppose setting y equals to x cube into e to the power minus x, this is the equation number 1. Using same procedure, we can find out the maximum or minimum of this function. Taking differentiation with respect to x on both sides, just taking ddx on both sides, we get this. This is the actually UV process. That means product of two functions. You must know from our previous lecture, product of how to solve of differentiation with the product of two functions. First function into ddx of second function plus second function into ddx of first function. That means u into ddx of b plus b into ddx of u. UB process, rule 1. So e to the power minus x formula, you must know ddx of e to the power mx. Formula what? M into e to the power mx. This is the differentiation of e to the power mx. Just multiplying with the coefficient of x. Okay, after differentiation. So their coefficient minus 1 only. This is why minus 1 into e to the power minus x and e to the power minus x and x cube differentiation power rule x to the power 3 into x to the power 3 minus 1. Just simplifying, we get this. Okay. Now first derivative is this actually. This is the equation number 2. Now first condition for maximum minimum value, what will be? First derivative will be 0. That means dy dx equals to 0. So this equals to 0. Okay, because dy dx equals to this. So just solving for x, because e to the minus x can never be 0 for any x of real number. So this not equal to 0, remember it, e to the minus x. So this product must be 0. So either x equals to 0 or 3 minus x equals to 0. So we get two values for this. And this is the critical value because first derivative setting first derivative equals to 0, we got these values of x. So these are the two values are critical points. Now again taking the differentiation with respect to x on both sides of this. That means double differentiation. So second derivative or second derivative test, taking the dx on both sides, we get d square y by dx square equals to again ub formula. X square first function and second function is this product. Okay, first function ddx of second function plus second function into ddx of first function. So again this is the product function. Again this is the product function. This is the product u into ddx of b plus b into ddx of u. That means first here another product function rule. Okay, so and this is the e to the power minus x, 3 minus x and 2 into x to the power 2 minus 1. So x square e to the power minus x and 3 minus x differentiation 3 will be 0. So my x differentiation 1, this is for minus 1 plus 3. Again x square into this 3 minus x differentiation of this minus 1 into e to the power minus x, just using the just previous rule. So again x to the n formula and simplifying we get this one. Okay, so second derivative is this value 3. Now the second, for the second condition, the second derivative test, for there are two values, critical values, one is 0 and another is 3. So for x equals to 0, second derivative value what? 0. Remember that if second derivative value is 0 at x equals to 0, so there will be neither maximum nor minimum. So the function has neither maximum nor minimum value at what? X equals to 0. So the given function has neither maximum nor minimum value at x equals to 0. Now again for testing x equals to 3, just putting x equals to 3 in second for second derivative test, x equals to 3, we get minus 9 e to the power minus, because this is the negative values for any values of e to the power minus 3. So we get negative, this is negative. This is why so the function has maximum value at x equals to 3. And the maximum value is from equation 1, just from equation 1, we are putting x equals to 3. Okay, x equals to 3 cube and e to the power minus 3. So 27 e to the power minus 3. And the given function has only the maximum value, and y max equals to 27 e to the power minus 3. And the function has no minimum value at x equals to 0, remember it, or maximum value at x equals to 0. So x equals to 0 is the inflection point here. Okay, just y equals to x cube e to the power minus x has only one maximum values, and this is the this value is 27 e to the power minus 3, and it has an inflection point. Okay, x equals to 0 is the inflection point, because the inflection point, which one? If at any point of a curve, if we don't get any maximum values or minimum values, or any concave up or concave down, if we don't get, okay, then that's points will be the inflection point. So it has only one maximum values and there is no minimum values for this function. So thanks to everybody. Today actually we have discussed about how to find the maximum and minimum values of any function. And if you try to solve these types of function for finding maximum and minimum values, and you can easily solve the optimization techniques or optimization techniques, that means finding maximum values and minimum values. Optimization means what? Finding maximum or minimum values of any given function. And you can optimize also maximum profit, minimum cost in business application or in economics application. And you can maximize the revenue. Okay, you can optimize the cost of any farm of a or in an industry. So to minimize the cost and maximize the profit, it is the main fundamental problem of business or economics. So first of all, if you do practice this, then you can solve any optimization techniques. So thanks to everybody. Best wishes for you.